All right, check this out. I just filled up my Gatorade water bottle with some ice water here, and I walked outside, and it's a pretty hot and humid day. And I'm not sure if you guys can see this. Let me set this down in my car here. Let me see if you guys can see this. There's a film of condensation on here. See, when I wipe, it kind of goes away. So what's happening, and my finger's just a little bit wet. You can see it's a little bit shiny from the water. But in there's a bunch of water droplets on the outside right there. And let me go ahead and wipe those off so you can see that. See the difference here between this dry and this wet? Now if we let this sit for a little bit, you can see water already beginning to form back up on the water bottle. Let's go ahead and do that again. I'm going to wipe it off. And I'm not doing any tricks, but there's still water forming on that outside of that water bottle again. Or there's condensation. And the big question is, why? Why is that happening? All right, for us to really understand dew point and why that dew formed on the outside of the Gatorade bottle, we have to consider heat transfer and phase changes. This is a little bit of a review, something we already talked about in class. We talked about absorbing heat. So when ice absorbs heat, it'll melt into water. That's a phase change. And then we talked about when a water absorbs heat, it will evaporate and turn into a water vapor. Then we talked about the opposite, where you have the water vapor that can release heat and it will condense back into a liquid. So condensation is a really important thing for us here. That involves something releasing heat and then going from a water vapor back into a liquid. And then lastly, we have freezing, and that's where you have your liquid releases heat even more and turns into a solid. So how does that apply to what we're talking about? Let's take a look. Here's a scenario very similar to the Gatorade bottle. Here's a glass of ice water sitting on a table. And after a little bit, that ice is going to begin to melt, and you're going to start to get these dew droplets around the outside of the glass. And the original question is why? Well, we just reviewed those phase changes in energy transfer, and everything we're going to talk about relates to one of these three processes down below. We either have to do with absorbing heat, releasing heat, or condensation. So let's take a look. So shortly after ice is added to water, the ice begins to melt. Now, why does the ice begin to melt? The ice begins to melt because it begins to absorb heat. And as the ice absorbs heat, what's going to wind up happening is the water is going to release heat. So we have heat being released from the water, and we have the ice absorbing that heat. That's why the liquid gets cold, and that's why the ice melts, because there's a heat transfer going from the water into the ice, thereby melting the ice and making the water colder. Well, as the water gets colder, something else is happening as well. The surrounding air is also releasing heat. And as the surrounding air is releasing heat, now that surrounding air that's releasing heat, that's going in to help melt the ice as well, which is also making the surrounding air cooler. So now the air surrounding the cup is actually getting colder, and you can try this. Take a Gatorade bottle or a glass of water, fill it with ice water, and put your hand about 6 inches away or so, about here, and then slowly move your hand towards the glass, and you're going to feel the air surrounding the glass getting colder. So why is that important? Because the air is getting colder, what's going to happen is that any water vapor in this surrounding area is also going to lose its temperature. And if you remember about our energy transfer conversation a little bit ago, when water vapor releases heat, it's going to go ahead and condense. And so you're going to get condensation here, and you'll get condensation over here. And that condensation will build up on the side of the glass. Why is all that happening? Because you've reached the dew point. And remember, the dew point is the temperature at which water vapor will condensate after there's been a release of heat and something is cooled down. So if we drop the air temperature down, then the water vapor will condensate out of the atmosphere. That is to say, it will go from a vapor to a liquid, and it will attach itself to something like the side of this glass, or maybe dew in the morning grass, or maybe you get that haze of water on the buses in the morning and you draw smiley faces. That all happens because the water vapor in the atmosphere has reached the dew point. Now, why is this important? Because this helps us understand condensation in the atmosphere, and it also helps us understand the formation of clouds. I hope this clarifies for you what dew point is and how it relates to energy transfer and condensation. Please let me know if you have any questions.